All right, in this video we are going to be covering sketching polynomials when it is given in factored form. All right, so before we even get into this, we want to talk quickly about intercepts, and we're going to talk about x-intercepts, all right, x-ints, x-intercepts, and we're going to talk about y-intercepts. All right, and again, an x-intercept is just where we cross the x-axis. We've been dealing with these for a while in our math career, likely. But x-intercepts occur when f of x is equal to 0, when our y value is equal to 0. So there can be multiple x-intercepts. That's possible. With a function, there is not an opportunity for there to be multiple y-intercepts. All right, there can only be one y-intercept, and that occurs when x is equal to 0. If we had multiple y-intercepts and you graph the function, it is not going to pass the vertical line test. Also, if you plug in x equals 0, you should only be able to get out one value. So our y-intercepts occur when x is equal to 0. So let's look at kind of a basic polynomial here. Okay, we have f of x is equal to x minus 3 times x plus 2. Sure, we could factor this out. We could turn it into vertex form. But when it's given to us in factored form, we're really focused on the intercepts. So if we were to FOIL this out, we know that this would be, this would be an x squared. So the degree of this function would be 2, and the leading coefficient is positive, right? This is a positive x times a positive x, which gives us positive x squared. So that tells us for our end behavior, on the left side, our arrow is going to point up, and on the right side, our arrow is also going to point up. Then for x-intercepts, that's when f of x is equal to 0. Well, when is 0 equal to x minus 3 times x plus 2? That's just at x equals 3 and negative 2. So at negative 2 and at 3 there. Our y-intercept occurs when x is equal to 0. Well, what is f of 0, right? When x is equal to 0, I just plug in 0 for x. 0 minus 3 gives me negative 3. 0 plus 2 gives me 2. So negative 3 times 2 gives me negative 6. So my y-intercept is negative 6. So my graph is going to look something along these lines. I can see my arrow on the left is pointed up. My arrow on the right is pointed up. I cross through the x-axis at x equals negative 2 and at x equals 3. And then I cross through the y-axis at y equals negative 6. All right, and so, yes, this is a quadratic. This is very basic. We know how to sketch quadratics. But now we're going to apply that to higher degree polynomials. So like polynomials in third, fourth, fifth, etc. degrees. All right, so dealing with this g of x now. We have g of x. The first thing I like to do is identify what the end behavior is. All right, and I like to do that just by showing arrows. Okay, I know that this is going to be a positive x cubed function because I'm multiplying positive x times positive x times positive x. So that's a positive x cubed. Well, think about it. That tells us on the left side my arrow points down. On the right side my arrow points up. Then my x-intercepts are going to occur just when the function is equal to 0. So at x equals 3, x equals negative 2, and x equals positive 1. So let's get those on the graph. Negative 2, 1, and 3. And then my y-intercept, well, just set x equal to 0. That's going to be negative 3 times 2 times negative 1. And negative 3 times 2 gives me negative 6 times negative 1 gives me a positive 6. 1, 2, 3, 4, 5, 6. All right, my arrow that goes to the left should point down. So from here, I'm just pointed down. I'll go up, touch this y-intercept, come back through, and then go back up, and my arrow on the right should point up. All right, so the only places that I'm crossing the x-axis are at negative 2, 1, and positive 3. My left arrow points down, my right arrow points up, and I also cross the y-axis at y equals 6. Let's do another example together. For this next one, h of x, it is very similar. The only thing I changed now was I changed this first term to a negative x. So let's see how that affects the graph. Well, starting with end behavior, well, my degree is still going to be the third degree, right? It's x cubed. But now it's a negative x times a positive x times a positive x, which is going to give us a negative x cubed. So now instead of the left arrow pointing down, the left arrow will point up. And instead of the right arrow pointing down, or sorry, right arrow pointing up, now my right arrow will point down. My x-intercepts, well, when is negative x minus 3 equals 0? Well, that would mean negative x has to equal 3, so x is negative 3. X equals negative 3, negative 2, and positive 1. And my y-intercept still winds up being negative 3 times positive 2 times negative 1, which is still a positive 6. So let's graph this new function. Let's graph h of x. 1, 2, 3. I have an x-intercept at negative 3, negative 2, and positive 1. My left arrow points up. My right arrow points down, and I still go through 3, 4, 5, 6, a y-intercept of 6. So I go down, come back through, up, and then come down. So again, you cannot cross the x-axis anywhere else except for these 3 x-intercepts. We know if it's x cubed, it can have at most 3 x-intercepts. All right, so if you drew extra, unfortunately your graph is incorrect. All right, let's check out another one. So the only thing that changes with this problem is now we have this squared here. So we're actually going to use Desmos to kind of see how does this squared affect our graph. Well, let's start. I'm going to multiply. Let's find our end behavior. I have negative x, so negative x, times x squared, so negative x times x squared, and then times another x. So negative x times x squared gives me negative x cubed, times another x gives me, that's a negative x to the 4th. Well, it's an even power, so the arrows point in the same direction. It's negative, so both of those arrows will point down. Now we talk about our x-intercepts. Well, our x-intercepts are going to be, for this first one, negative x plus 4. That's going to be x equals 4. For the second one, x minus 2, that's just x equals 2. And this squared, I'm going to say this has a multiplicity of 2. And multiplicity, guys, is really just the number of times that that 0 occurs. So we could say, that 0 occurs twice. And we're going to see what happens with the graph of that. And then I have x equals negative 1 for the last one. All right, this one had a multiplicity of 2. And then finally our y-intercept. Well, plug in 0, we're going to get 4 times negative 2 squared times 1. That's 4 times 4 times 1. That is 16. So my y-intercept is 16. All right, now the graph of this. Okay, this one's going to be a little bit trickier. I want to see, what is this multiplicity of 2? How does this affect my graph? So let's go to Desmos and take a look at this. Negative x plus 4 times x minus 2 squared times x plus 1. We'll get to Desmos. Where is Desmos? There it is. All right, sorry about this. I probably should have pulled it up earlier, but here's some nice time to relax and enjoy. Negative x plus 4 times x minus 2 squared, and then I believe it was times x plus 1. All right, let's see what happens to my graph here. What happens at x equals 2? Okay, what happens at x equals 2? Yes, it is a it is an x-intercept. However, at that value, it only touches the graph and then does not pass through it. It touches the graph and then bounces straight back up. Let's see, what were to happen if I change that to a 3? What if I change this to a cubed? Okay, if I change that to a cubed, oh, well, now it actually passes through at that point. It still passes through. What if I changed it to the 4th? Change it to the 4th. Oh, again, it touches it, but does not actually cross over the x-axis. So what we can conclude from this is whenever we have an even multiplicity of a 0, okay, whenever we have an even multiplicity, so whenever that 0 is occurring more than one time, or an even number of times, even multiplicity, the graph will not cross the x-axis at that point. At that value. Sorry, I ran out of room a little bit, kind of bad estimation of how much room I needed. All right, so if there's an even multiplicity, the graph will not cross the x-axis at that value. So for this, if we were to graph it, and again, I know we saw it on Desmos, but let's just graph it quickly. We have x equals 4, x equals 2, x equals -1. All right, both of my arrows point down, so this goes down here, this goes down here. My y-intercept is +16. I don't know, that's like way up here. All right, so now let's see, how are we going to do this? Well, at -1, that only has a multiplicity of 1, right? That only occurs one time, so mult of 1, which means that it crosses through. So we'll cross through there. We'll come up to our y-intercept. Then we're going to loop back down. But at x equals 2, it has an even multiplicity. So instead of crossing, it kind of curves and just goes back up. It hits that point and then, boom, stays on the positive side. Then eventually it'll curve back and pass through because at x equals 4, that only has a multiplicity of 1. All right, hope that you guys enjoyed this, and I hope that this helps you out with the problems coming towards you. So have a great rest of your day.